Hello everyone, in this video we are going to see linked list deleting a node. Here we have one linked list and we are given one data like 300. For example, you can take this node and we want to delete this node from this linked list. Deleting a node in the linked list is a bit complicated compared to the insertion and searching or printing the data. So watch this carefully. This is one of the most frequently asked questions during the interviews. Okay, there are three scenarios when we are deleting a node will happens. So first one is I can delete the node at the beginning. So deleting node at front, this may happen, and deleting at the middle, it may happen, and deleting at the head, it may happen. So you have to handle all these three scenarios in one function itself. So how do we do this? We'll see in this video. Okay, when I delete this head node, what and all the changes will happen? Okay, how do I delete is I can just go and make my pointer to the next node. So that case is there. When I'm deleting at the first node, I'm just how to point this one to the next of this next node, and I can just delete this with the free functions. Okay, the next condition is how do you delete the nodes at the middle? Here what I'm doing is I have to pick this pointer and take out this pointer also, and I can just point it to this one so that my node will come out of it, and I can remove this pointers in this node. This is how you have to delete at the middle. And then how do you delete at end is you can just go to the end node, which means the last node, and you can just delete that, and you have to give your tail pointer to the previous one. Okay, and you can remove this to null. Then this node will be free, and then you can delete this. Okay, these are all the three cases involved here. Here you can think there is only one node is there. How do I delete this? For example, you're having this kind of node. Here only 100 is there. Their head and tail is same. By that time, what do you do? So those kind of conditions, we'll handle that in this video. Okay, now you can see the code snippet to solve this problem. What I have is I have previous pointer to denote the previous node and a current pointer to denote the current node, and I'm executing this code until the end of this node, from the beginning to end of this node. That's the reason I have assigned it to head. Okay, here, and my previous pointer, because when it current is at the head, the previous pointer obviously will be null. So that is also written in the second line. Okay, I have to continue my execution of the program from the head to tail. So while of current it exists, and inside of it I have to continue the functions only my expected data is equals to the node's value. So that's the time only I have to take care of this deletion part. If it is not at all there, you can just skip it. I just alter these nodes, and this is my head and tail. Okay, here in this node, for example, I'm going to delete this 300, and here in current data it's equals to my expected data, so it is equal to 300. Okay, my actual problem is this only these lines. Okay, now I'm taking this node as current node, so this current node will become here, so this value will be 300. Okay, how I'm iterate this current is two the pointer which moves over this list. So when this current pointer moves, the previous pointer also will move to the next position, so that my head and tail pointing will become easier for me to do. Okay, now the current is in the 300 and the previous is here in this one. So previous will be 200 and the current is 300. So previous is pointing to this one and current pointing to this 300. Okay, now what I'm checking is whether my previous is existing or not, because it may be like head node also and tail node also. So what I'm doing is for here at line this, if p the previous, checking this is existing or not, so that I can remove the pointer from the node of this 300 and point it to the 400. So that's the reason I'm checking. So what I'm doing is, if p existing, then I'm moving this current nodes next, which means the 400 as this previous next. So this is the line actually does your job. What it is means, from this current nodes next, currents next, that is nothing but 400. Then I am taking this next of this previous. So previous next equal to currents next, so that this pointer will come here. Okay, now this is also pointing, so this is a pointer where we have given is this del equal to current. So this is here, you can see this del equal to current means this is the node which I'm going to delete. Okay, now one more condition is here, in case this is a last node. So you can think of this is a 500. In this case, this previous next, I'm checking there is nothing in the previous next. Then I have to give it this as tail pointer as this one, because there is nothing, because I'm deleting this 500 means this is 500 and this is 400. You can think of this scenario when I'm deleting this current. I've given this previous this current's next is nothing is there, here it is null, so only null is there. But this node 500 carries one more thing also called tail, so I need tail pointer. So if I delete this 500, what my tail pointer will be is nothing but this node, the previous node. So I'm checking that previous next, that is null, which means not of previous next, which means equal to null. That time my previous is the actual tail pointer, so I assign in that one. Okay, this is at middle and end it covers. Okay, what the case when I'm having the node at the head itself and I'm deleting it means, you can just skip it to the next node regardless of whether it is null or not. You can just skip it to the next node, and this node you can just delete this del node because it's in the current value. This is the case for at the beginning you're deleting, and this is the case at middle and end you're deleting. And this line is for p equal to current, is for just traveling to the next line, because when I'm going to the next one, I give my backup to previous from the current, and then only I can move with that is what this p equal to current, and current equals to next. Okay, hope you understood this line under this snippet of code, and we'll go to Visual Studio and start to implement this, and then we'll write various combination of deleting at the middle, front, and end, and we'll print out the data. Okay, here in Visual Studio Code, in first line I have necessary importing statement, and this is my class definition of list node. Here I have integer data and next pointer constructor for the same, and this is my driver functions, and here you can see those constructor and append functions for all these attaching nodes, and here we will write the delete functions. And in int main, I have appended some of data to that list and print that data, and we'll write the delete operations here. Okay, void delete Here I have to give that expected data, so int expected. Okay, now what I need is I need two pointers for current and previous. So what I do is list now current and previous equals null. My current is nothing but my head, so head, while I have to continue this execution until my current existing. Okay, now I have to travel to each and every point nodes using this current pointer. So current equals current next. Okay, before I'm moving my pointer from current to next, I have to give my backup in the previous pointer. So I have to write previous equal to current. Okay, I have to delete only my data is equals to the expected data. So current data equals to expected data. So you can give current equal to expected data. Once I find that data or delete that data, I have to break it and I have to return it. Okay, so that statement also done. Okay, in this one you need a del like pointer to denote a current pointer because you're going to free that. Okay, so what I'm doing is list node, I'm going to delete this del and I'm going to give it as current cur. Okay, before breaking I have to free that, so free that del. Okay, and now what I'm doing is, this is the case you have to handle separately because you're maintaining this head and tail pointers. So how do you handle these two cases? So when p exists, which means the previous exists, when it is head node, if you're deleting, the previous node will be null. So that time you can just point this to here, to the next node, and you can delete this and then you can return. So what I'm doing is, if previous is null, so that time you have to write when is previous is existing for this case, and else case you can give this. So I'm giving pre is existing. Pre existing means that will be for middle and end, and else cases it's the beginning. Okay, we'll cover these two cases. First we'll cover this at the beginning. We'll cover what we have to do is we have to just switch that pointer from head to the next node. So what we do is head equals currents next. Okay, now we'll handle at the middle and end. Okay, here I just make this one. When it is here, you can see when it is in 400 and the previous will be 300. So this is a not null, so at the if condition it will go inside. So what I do is I'm taking this previous pointer and putting that in the currents next. Here this is current and this is next, so my previous next equals to the currents next. Okay, I write that line also, p pre next equals current next. Okay, that case is done. Currents next can be null also, even that is null, that case you no need to give. Okay, I told you this condition also already. When you're deleting, this is a 500 and this is a 400. In case, as you can see this, I'm going to do the same, but here it is null because this is the tail pointer. It is pointing to null. Okay, what I'm doing is I'm picking this pointer and I'm pointing to null. Okay, that's fine, but you're going to delete this current node here in this line because this current reference and del reference is same. So when you strike this off, you have this tail pointer. So you have to point if the previous next is null. That's what written in this one. This not means you're checking for null condition. It's for toggled. When previous next it's equals to null, you have to give this tail pointer as previous. So what I'm doing is if previous next equals null, what I'm giving is tail pointer equals to previous. Okay, so all my edge conditions are satisfied now. Okay, here you can see my append functions. You have to handle this case separately. In previous video it's not covered because you can think of it, there, if this code is not there, okay, in previous video it will be like append only this head and tail pointers will be handled. Here in the tail pointers, tails next, you can consider that I have deleted all the nodes but nothing is there. So when I'm accessing the nulls next, it will be throwing the exception. So that's the reason we have to give, if tail or head is not existing, that time you have to assign this list node directly to that head or tail. Okay, so head or tail not exist, you have to assign head equals tail equals y and return. This case must be handled separately, okay, in the append function. Okay, now I just execute my code and I'll see the what's the content of it. Okay, 1 2 3 4 5 6 is there. Okay, I'll now what I do is l dot delete. I'm deleting node 1 and I'll print it, l dot print. Okay, now you can see this one is deleted. I have this 2 3 4 5 6. Okay, now what I do is I'll delete the node 6. Here I'll delete this 6, l dot delete. You can delete the 6 and print it, l dot print. You can see this 6 has got deleted. Okay, after that deleting, I'll append that node and print it. So we can no need of this one. What I do is l dot append. I can add this 7 and print it, l dot print, in order to make sure that head and tail works perfectly. Okay, 6 is deleted and 7 is appended to this. Okay, that appending also is working fine. And in the middle I'm going to delete this 3, so I can delete this 3. Okay, here this 3 got deleted. Okay, fine. Now I have this only one node is there, so what I'll do is I'll just print it, l dot print, and I'm going to delete the same, l dot delete this one, and then I'll add this l dot append to, and I'll print it, l dot print. Okay, here in this line you can see this one got printed, and I deleted that one also, and I appended that two to the list, and I printed this two. So all my test cases and scenarios are working perfectly with all these cases are handled. Hope you understood this problem. It's a bit complicated when compared to the searching and other functionalities. So hope you understood this problem and the solution for this. And thank you for watching this video. We'll meet in the next video.